So let's look at circular motion and this problem in particular. It says a car rounds a 20-meter radius curve at 10 meters per second. The magnitude of its acceleration is what? Well, first thing we want to do, look at this. It's going to go around a curve. This is going to be my car. It's going to go around the curve. And the curve is going to have a radius of 20 meters. So from its center, it's 20 meters. And the car has a velocity, has a speed, magnitude of 10 meters per second. The speed is constantly changing, or the velocity, let me rephrase this, the velocity is constantly changing because its direction is constantly changing. Up here, it's going in that direction, down there, down on the curve, it slowly changes direction. So that means its velocity is not constant, even though its speed is constant. So we're doing a circular motion, and we know circular motions are governed by centripetal acceleration. The acceleration required to change the direction of this velocity vector by keeping the same speed is equal to v squared over r. How much of a radius does it change by, and what is our speed around that curve? One thing to be very, very, very careful on is to make sure that the radius is given. A lot of times you'll see in physics problems, they'll give you a diameter. You don't want to use the diameter, you want to use the radius. So if you ever see a diameter, instantly convert it into a radius by dividing by 2. Okay, so let's go through, plug in some values for this. It says that we have 10 meters per second, quantity squared, and we're going around a curve of 20 meters in radius, which is 100 over 20 meters per second squared. Meters squared, seconds squared, divide by meters. My units still work out. 10 over 2 meters per second squared, which gives me a grand total of 5 meters per second squared as my acceleration. So I come up with answer choice C as the right answer. Not that hard of a question, but just a good one to try. Make sure that we can do what we're trying to do.